Hi folks, CodeTutor here and my name is Anil Deshpande. The next one is method injection. This is pretty straightforward. Have a look at this particular code. You have a method called filter countries which takes a filter criteria. Well, it is a dependency that is being passed as a parameter to this function called as filter countries. So dependencies are passed neither through constructor nor typical setter. They are just being passed as a method or a function parameter. For all practical purpose, these are like method arguments that you typically see in any parameterized methods or functions. Now the question is, why do we need it, or why would you rather use this mechanism over other things? The very common reason could be the dependencies are needed temporarily within a specific method. You don't need it at the scope of the object. That could be the reason. And also these are useful for testing, for mocking purposes. That's also one of the reason why you would like to use this. There are no disadvantages as such with this mechanism. Probably you have to be a little bit cognizant of the fact that these have only method scope or a function scope. Once function execution happens, these dependencies are not available to be used across other methods that might be there in the class. But other than that, there is no disadvantage as such. Well, the next kind of dependency injection is ambient injection. Well, what do you mean by ambient? It's basically relating to something immediate, surroundings of something. So that is why the term ambient noise reduction or ambient noise. So it is always available immediately in the vicinity. That's what ambient is. Now, how is this related to the dependency injection? Let's take, for example, this piece of code. Here, we are using local context.current to get hold of the context in a main screen composable. Let's take another example. Here, I have class which extends application class, which is Android's application class, and you basically declare a variable, global variable inside this particular application. And because the global variable is part of my application which extends application, now I have access to the global variable anywhere and everywhere in the code. You see this or a different variant of this used quite very often in any Android application. In this case, I am trying to get hold of a string using the context.getString method. In this case, I am trying to pass the context as one of the parameter to get hold of the color in the theme of my application. And then I am trying to get hold of the shade preference using the context. So the context is pretty much available everywhere in your Android application. And that is the reason why it can also be called as context injection, specifically if you are talking from the Android's perspective, but the general term is ambient injection. The advantage of this kind of dependency injection, where you are not really passing it as an argument to class, constructor or a setter, it's always available. There is ease of access. Dependencies are readily accessible from anywhere in the application. It basically reduces boilerplate code that you may have to write for passing the objects. So you don't need that. So it reduces that complexity. So it makes it easily accessible everywhere. And then it is available as a centralized configuration. All the dependencies are managed in one place, and it makes it easy to control and update the dependencies using the ambient or context injection. And then it is very simple. It is simple to implement and understand, especially for smaller projects or prototypes where quick access of shared service is needed. And then the runtime resolution, because it supports dynamic resolution of dependencies, which can be really useful in scenarios where specific implementations need to be chosen at the runtime. But then there are disadvantages of this particular mechanism. The first one is global state issues. Because everything is being managed globally, it relies on a global state, which can lead to hidden coupling, making the code harder to understand and debug. And it creates tight coupling because components become tightly coupled to the centralized context object, reducing the flexibility and making the system harder to modify or extend. And since your code becomes difficult to test, because how would you be able to mock or replace dependencies in unit tests since they are accessed directly from the global context, making the testing a little less effective. And then the dependencies are now hidden. They are not explicitly declared, making it difficult to trace what a class or a function depends on. That reduces the clarity in the code. Because it is a centralized shared context object, the thread safety becomes a major issue. It can create major concurrency issues if multiple threads try to access the shared context without proper synchronization. And this reduces the scalability. As application grows, managing the global context becomes increasingly complex and error prone. So the default context that you can use it, but don't try to rely on this too much for your own passing of dependencies. So this is not a very recommended approach of dependency injection. I would rather say it is almost a kind of an anti-pattern. Don't use it until and unless it is a small project or a prototype where you want to quickly test out certain things. For that purpose, it is okay, but for large scale projects, it's not recommended. Then comes the static injection. And as the name suggests, we are using a static class here to create a container for holding different objects that I would be needing across the application. And since we are using Kotlin, in Kotlin, you use object to create a static. So in this case, I have a object called config, and that has a static variable at the config level, which is database. You have methods, set database, get database. Once I have this, I can just use the config.setDatabase to set the database and then get a database and create a query on that particular database. Once again, static injection has lot of issues. The first one is global state. Static dependencies create a hidden global state, making the application harder to test. Then it creates a very tightly coupled code. Classes become tightly bound to a static dependency, making it harder to modify or extend the system. And then that reduces the testability. Anytime you see a static class being used in the code, be 100% sure that becomes very difficult to test. It basically is going to put a spanner as far as writing the test cases is concerned. Then it can create memory leaks, especially in case of Android. We have seen this happen where the views, the composables, the activities and fragments, if they start sharing a static instance of a context, memory leaks are bound to happen. And that will start affecting the performance of the application. And it also creates lack of flexibility in your code. Your code doesn't scale very well as the time passes, and that basically means it becomes harder to test the application. So there are a lot of problems with this kind of dependency injection, which is static injection. But does that mean we don't use this at all? We use this, but in very few instances. For example, let's assume that you have a legacy system where refactoring an existing system to use a proper dependency injection is almost impractical due to time or budget constraints. Then this is one of the technique you can use. Or think of a situation where there are shared resources. For classes that manage shared resources like logging utilities or configuration managers, a single instance is required throughout the application. And in that case, using a static dependency injection really makes sense. And in cases where you need a very quick and dirty solutions as a temporary measure where simplicity and speed is prioritized over maintainability. But otherwise, I would not recommend this static injection in your code. So we have gone through quite a number of dependency injection techniques. All of these dependency injection techniques can be managed or implemented manually without any special dependency injection frameworks. But the last one, which is field dependency injection, is slightly different from all of this. It is dependent on some kind of a dependency injection framework to actually make it work. So in the next video, we will try to understand what is field injection, how it works, and when to use it before we actually start using it in the next upcoming videos. So stay tuned. To the end of this particular video. Don't forget to like, comment, share the video and subscribe to the channel. Take care. Bye.